Spectrophotometric Determination of Manganese and Steel Lab Video Part 1. These videos are designed so that when you are watching them, you can follow along with the procedure in the lab manual, record data that you would normally collect in lab, perform necessary calculations, and ultimately hand in a lab report as if you had completed the lab in person. The requirements for the lab report. An abstract. You'll write an abstract as you normally would with the final results of the lab included. There should be 2 separate results listed for the percent manganese and steel, one for each trial. Each should be accompanied with a standard deviation and RSD. Lab notebook pages. You will write in your lab notebook as you normally would to record data and perform necessary calculations. An Excel file. You will hand in an Excel file containing a linear graph for each of the 2 trials that were performed along with the tables necessary to complete the graphs. In addition, any other calculations that were performed in Excel should be labeled and included in the file. Error analysis. Equation 5-10 in the text should be used to calculate the error in the x-intercept, and the total error should include the error associated with the 25 milliliter volumetric pipette and the 250 milliliter volumetric flask. These calculations must be shown in Excel and or your lab notebook. And then there's also going to be some periodic questions. In addition, several questions will be asked during the video that must be clearly answered in a separate Word file. The questions will be labeled as 1, 2, etc. in the videos, so you don't need to rewrite the questions. Only label the answers with the appropriate number. And finally, you're given calibrated values for a 250 milliliter volumetric flask and a 25 milliliter volumetric pipette that can be included for all of your calculations. So let's get started on the procedure. Steps 1 and 2 in the manual involve dissolving specific masses of a manganese standard and duplicate steel samples in nitric acid solutions, and then bringing them to specific volumes for further preparation. So we're going to be weighing by difference to obtain an accurate mass of the manganese standard. Make sure to record the initial and final readings on the balance. And make sure you perform the necessary calculations in your lab notebook. We have our container of the manganese standard. And here's our initial value on the balance. And we're going to dispense some into the beaker that we're actually going to use to digest the sample. And here's our final reading on the balance. We're also going to be weighing by difference to obtain duplicate samples of a steel unknown. The unknown steel sample will contain approximately 1% manganese. You will need this value to perform the calculations of how much steel is necessary for each sample. Remember to record the initial, intermediate, and final readings from the balance. Here's our initial reading. And we're going to put some of that into the beaker that we're actually going to use to digest sample number 1. Here's our intermediate reading. Now we'll move on to sample 2. Well, looks like we didn't pour out quite enough, so we're going to pour out just a little bit more. And here's the final reading. Question 1. Explain why weighing by difference is the preferred method for obtaining accurate masses of samples. Hint, refer to page 1 of Basics Review and Calibration of Volumetric Glassware in the manual. So we're going to need to prepare 250 milliliters of a 3 molar nitric acid solution using a concentrated 15.8 molar nitric acid solution. An ice bath will be used for this preparation, and remember to perform the necessary calculations in your lab notebook. When we mix concentrated acids with water, it's a highly exothermic reaction, so we want to make sure that we keep the temperature low for this process, and so we're going to use an ice bath. First, we're going to put some water in the beaker, so we can be adding the acid to the water. And we'll let that sit there for a couple minutes to make sure the water gets cold. And we're going to dispense out the necessary amount of the concentrated nitric acid using a graduated cylinder. Then we're going to slowly pour that into the cooled water and maybe occasionally stir it and just monitor it to make sure it doesn't look like it's heating up to an excessive level. Okay, so now that we've added all of our concentrated nitric acid, we're going to bring the level up to 250 milliliters with our DI water. So at this point, we're going to take the beaker out of the ice, maybe dry off the outside of the beaker a little bit. And we're going to put a label on that beaker to make sure we remember what's in that beaker, or if somebody else comes along, they can see what's in the beaker. Question 2. Why is an ice bath important when diluting concentrated acids? And why is it important to add water to the beaker first, then add the concentrated acid to the water? So now we're going to be dissolving the standard and the unknowns in 3 molar nitric acid. In this step, the manganese standard and the unknowns will be dissolved in 3 molar nitric acid and boiled to completely dissolve them. By the way, these are two separate steps in the lab manual, but it's just more convenient if we combine these two steps in a sense and start heating all three of our samples at the same time. And then we're going to put a watch glass over the top of the two unknown steel samples. So now we can see after heating for a while that the manganese standard has come to a boil. And so we're going to take that one off and we're going to prepare that sample first. And we're going to let the unknown sit on the hot plate for a little bit longer. Maybe we'll put those more towards the center of the hot plate so that they can start boiling. So now we're going to start preparing the final volume of the standard. The standard is diluted into a 250 ml calibrated volumetric flask and then transferred to an Erlenmeyer flask. We're going to want to rinse this beaker out a couple times with DI water to make sure that we get a quantitative transfer of our standard. And then we're going to bring this to volume with more deionized water. And then we'll use either our medicine dropper or squirt bottle to bring that volume exactly up to the mark. And finally, we're going to want to invert this flask several times to make sure that our mixing is complete and uniform. Finally, we're going to pour that into an Erlenmeyer flask because we need to use our calibrated 250 milliliter volumetric flask for a 1 to 10 dilution. Question 3. After the standard was initially diluted to 250 milliliters in a volumetric flask and poured into an Erlenmeyer flask, why wasn't the volumetric flask rinsed with water to get any remaining standard and added to the Erlenmeyer flask? Now we're going to dilute the standard by a factor of approximately 10 using a calibrated 25 milliliter volumetric pipette and the same 250 milliliter volumetric flask. Remember, your final concentration will be approximately 1/10 that of what you were originally calculated. So let's assume that our calibrated 250 ml volumetric flask was rinsed out before we're going to do this dilution. Okay. And now we can just fill that volumetric flask with deionized water to the mark. So now we're going to want to invert that flask a few times again to make sure it's mixed up well. It's always important when we're getting standards that are in volumetric flasks. And then finally we're going to transfer that to a beaker that's labeled Manganese Standard. And put some parafilm over the top. Now that we've prepared our manganese standard, we can start to prepare the solutions of the unknowns. First, we're going to need to weigh approximately 1 gram of potassium persulfate for each sample. It will be added to the solutions to oxidize any carbon to carbon dioxide. We'll use the tearing function for this. So we're going to put an empty weigh boat onto the balance. And we'll tear that to 0. And then we'll add enough potassium persulfate to get to about 1 gram. Nope, not quite enough. That looks good. And that looks good for our second one. Question 4. Why is it okay to use the tare function for weighing out the potassium persulfate, but not okay for weighing out the standards and the unknowns? Now 250 milliliters of a 0.05 molar solution of nitric acid must be made from the 3 molar nitric acid solution that was made earlier. Make sure to show your calculations for this. So for this one, an ice bath isn't necessary. We're just going to be adding a little bit of 3 molar nitric acid to about 200 milliliters of water. And then we're just going to bring that up to the 250 milliliters with more deionized water. Now potassium persulfate will be added to the samples to oxidize carbon to carbon dioxide. So here we have our boiling unknowns. We're going to take those off the heat, let them cool down for a little bit, and then we're going to add our potassium persulfate to each unknown and put them back on the hot plate. At this point, we're going to let them boil for about 15 more minutes, and then we'll take them off the heat. So at this point, once our samples cool down, they can now be filtered and brought to volume. The unknown samples can now be filtered and brought to volume. So we're going to use a number 41 filter paper to filter our samples and a Buchner funnel. So we're going to make sure that we wet the filter paper with a little water from our squirt bottle before we start. Make sure it's seated down to the funnel. And then we can start filtering our first unknown. So this is where we're going to use our 0.05 molar nitric acid solution to rinse that beaker out. Make sure we make a quantitative transfer. We'll do that a couple of times. Now we can take what's in the Erlenmeyer flask and transfer that to our 250 milliliter volumetric flask. We're going to use some of that dilute nitric acid again to rinse out our Erlenmeyer flask now. Now we can fill our flask to the 250 milliliter mark. As always, we're going to want to invert this flask several times to make sure the mixing is complete. Finally, we can transfer this to a 250 milliliter beaker and put some parafilm on the top of that. So now we can move on to unknown 2. And we'll speed this up a little bit. We've seen this once before. So now we've prepared both our unknowns and our standard, so we can move on to lab video part 2.